just hey, how was just Said? Say it. Right now it's duplicated. How do I make it one screen? Yeah, if it was connected, the VGA is duplicated. Do you know how to do that or no? The VGA is duplicated. So see my mouse goes across, comes here.
Oh, you want it duplicated? Okay.
Yeah.
Okay.
In settings, okay.
So just setting, and you go to system setting and to display, and here mirror.
Okay.
Now, just apply it.
Yeah. Thank you.
Working?
Yeah. Check. Audio check. I don't know if you can check. 1, 2, 3. Pram.
There's no audio. Okay,
There is? It's working? Okay, and on the screen, under the live stream, what do you see?
You're still in the, when you said when there's still that open thing with the draft.
Okay.
Yeah, this side is working. So there's a delay.
So it's not bad. Soft news presenting. What's that? No. Okay.
This is good?
Yeah, I put the new Python 2 folder over there.
Okay. Where is it? Yeah. On desktop, right?
Yeah. Wait, I just gotta change one thing.
Okay,
Is it,
I see Drew on here, but the screen's still the same.
the screen's still the same, right? Okay.
Yeah.
I'll fix that. Okay, now what is there?
Still the infinity thing.
Infinity? Okay, no. Did you equal on desktop?
My code, yeah, I saw.
That's from the USB. Then
Yeah,
can you
let's try.
eject the USB, please?
Okay. Oh, eject it. Is it good?
Yeah, it's good now.
Okay,
where's the
perfect.
USB? Gotcha.
I'll just.
Yo, mouse is- No.
Let's have you say some things as if you're projecting to the whole class right now. So
Okay.
we're just checking how it is next door.
The
So-
sound quality?
Yeah.
Okay, sorry. What did I say? It's like, hi, welcome to Opencv. Sorry, Python 2 for Opencv. Is that good?
We're doing a sound check now, guys. So
Okay, yeah.
go ahead.
Everyone take a seat. This is, Heath, you look nice.
What? Yeah.
I like your shorts. Pram, you come here for a second?
You see these papers? Anyone that's helping with the workshop, what's it called? Take one each and pass it to everyone. Just take like one each and give it to them. Okay? To you too. It's like everyone helping with the workshop. Don't give the code to anyone else.
Helping with the
Was the sound quality good? It's good?
It says you and 20. It's like I need for code to it. And if you get stuff like from one of someone else, like you can easily spot the error. That's why I have it all printed out so you guys know. Yeah. So I'm taking it away. So like anyone that's helping, just take it and then pass it. Like that.
We're not doing real-time feed. We're going to do image processing, and I'm going to show you guys how to do real-time feed, but since you don't have webcams on computers, I'm just going to do it on mine, and you guys can see. Heath, let's play catch.
Okay.
Just kidding.
screen. Presentation to presentation. Share. Oh, wait, Dhwani, did you want?
Yes, keep it here. I'll take it when. What is the first one? Yes, right.
Can you adjust the first one? And plus 2 is the second. 1, 2. Wait, sorry. 1, 2, 3. We're going to do ball tracking and this is a play.
So the small community counts before. Oh, okay. Okay. It could be 70 people. I just wanted to give you all an interview with the application now because you were expanding a program to allow 70 positions. You're also expanding the age to include grade 7 and 8. And all of them into a free feature within a structure of the program. And as an applicant who has not been on the board, that will be applying to community with application that you process for your Oh, you already did your application. How do you know what to apply for? Engagement for what? What are the laws? These are common. I was like, that's what it is. Not in shot. Not in one shot. So you know what you do? You take your answer sheet up? You know what showed him? Trevor. It worked though. It actually worked for him. They got an extra like. So annoying. Here, get you here. Today I'm gonna teach you something. It's like this. It's like this. Make it. Everything is finished. Like I do for those automatically. Let me see the templates.
Where's the server slot? Look, I'm gonna give it to you first. Here's how you know. Candy is first one. This one they're gonna make on their own. We're gonna give them time to make it. First the Julie, that's the second one. All this comes with the tail, right? Like you don't show me how to know that. And then this is the third one. This is the first one.
Wait, but next year the recruiter is gonna be you guys.
Supposed to be. Anytime there's a space,
He doesn't want good enough.
the majority of the true will be based.
I was comparing the oh yeah, 3 and 2. One of his best was when I went to Toronto, there was a kids casino and you gamble candy.
Good thing.
Did you gamble candy? I have to. I did. I couldn't find anything back.
Guys, we'll get started in 5 minutes. We're just waiting on a bunch of other people. We'll get started in 5 minutes. Like, make sure computers are on. You should be already logged in, so we're not gonna. You want to go ahead and left down home? Yeah, that's it for notes on one. You'll just be coding, and so like, all you'll need is time.
I'm really here, we can do this PC. Parsing. Same thing. You'll lose a blanket. Oh wait, I have HT. Oh, get started.
Guys, we're gonna get started. So get settled down, by your seats. And so this is the third workshop for Community Code Day. The first one we did HTML and like web development. The second one we did Python. Just an introduction to the programming language. Today we're gonna cover like extensions, and so we're actually gonna do computer vision today. So you're gonna learn how to like process images, find faces in images or videos, or track objects in videos using Python. And so our instructor today is Dhruv Patel. He'll walk you through like he'll teach you all the code and stuff, and the actual images and videos that we're going to use for the code, I'll like distribute them. And if you guys missed the other past two workshops during Community Code Day, which is the actual like technology conference, it's happening this Friday and Saturday. We're actually going to have mini workshops, so not 3 hours long, just 2 hours long, and we're just going to like review all that we did in these 3-4 workshops. And so if you missed the first two, don't worry about that. You can get the code emailed by us, so send us an email. Or on Friday, Saturday, you can actually attend the workshops. And for Community Code Day, we'll talk about it more in the end. We have a huge lineup of speakers on different topics of technology. And so at the end of the workshop, we'll give you more information about that. So any question, and also at the back, there's water. Washrooms are, if you go down the hallway to the right, at the back, there's washrooms. And if an emergency happens, the nearest exits are like down this hallway or to the right over here and out the doors.
Can you just clarify or confirm, is the next one Friday, Saturday, or is it Saturday, Sunday?
Saturday, Sunday. Yeah, next one is actually Saturday, Sunday. May 26th, May 27th.
Right.
This is Saturday and Sunday.
So
My
not
bad.
on Friday.
No, nothing Friday, nothing Friday. May 26th, May 27th, Saturday, Sunday. And all the information is on communitycodeday.com if you're on the website. Okay, and there's water at the back if you guys need some water. Any questions before we get started? No? Okay, so Dhruv Patel from YC.
Alright, how's everyone doing today? Good. Just a show of hands, who is here for the Python 1 workshop? Just to see where we're at. And is anyone that wasn't here, are you guys all familiar with Python? Yeah? So who is not familiar with Python? Okay, so we'll just go over a few things before we start the computer vision stuff. But before we do all of that, I'd just like to go over a few things in Python. And so we discussed some of this last time, but I'm just going to review it. And so what we're going to do today is use a library. It's called Opencv. What this stands for is Open Source Computer Vision. And so we're going to be using, a library is essentially a package of code already written for you. But instead of writing all that code again, you can just use it as and basically import it into your new code. And so that's basically what we're going to do. We're going to use Opencv. We're going to use something called Matplotlib. Has anyone ever used MATLAB before? Or has heard of MATLAB? It's used very regularly in engineering courses. And so Matplotlib is also another library we're going to be using. And so all of these libraries are called make up packages which you can import into your new code. And so we're going to continue. And so how you install these libraries, you don't really have to go into your whole internet, go browse for the right library, because it's code and it's very specific, and you have to go install it, install zip files. So instead of that, we use something called pip. And so we've done it already on all of your guys' computers, but if you want to do this at home, all you have to do is run pip, which you can probably find more information online. And all it is that it installs Python packages for you. And you can install them on things called virtual environments, and all of this has been done for you on your computers. So yeah, you guys don't need to spend time like installing stuff. And so yeah, computer vision. So what is it, right? So basically what it is it's a way to process images and to learn for the computer to recognize different characteristics of that image. So if we're processing a face, we can look at where are the eyes on that face, or where's the mouth on the face, or does the person have glasses? So you can look at all of these things. And Opencv, again, it's the open source computer vision library. And so it's aimed at looking at things like machine learning, which has a lot of hype around it, but it's actually mainly for computer vision. And so what we're going to be doing today is we're going to be processing images, processing videos, and I'll show you guys how to actually do real-time feed as well. And so you can kind of have the camera on and recognize all these things at the same time while the camera is running. And so, and continue. And so image processing is basically all the different things we can do with images, right? So this is actually what we're going to be doing today is we're going to be taking an image and converting into something else, basically, so you can run a function on the image. And so this can have a lot more applications to things like if you were an engineer designing a blueprint rather than actually drawing out the entire blueprint. If you have a model, you can convert that to a schematic, right? And so that's what canny edge detection is, and we're going to get on with it. And so we're going to do this type of image processing, and I'm going to give you guys a challenge to do on your own. And so I'll get to that later. But so this is the first type of image processing we're going to do. It's called canny edge detection. So what it does is basically it finds edges on the image, and then it outputs it using the Opencv library and Opencv functions. And so it's just going to pre-process the, pre-processing is basically just taking the image from before, and it's going to run it through a bunch of layers of different algorithms. And so the next thing, that's all like a lot of math stuff, but the cool part about having all these packages and libraries is that you don't really need to know all the math, right? Who wants to do all the math by themselves, right? So you can just go use these libraries, and these libraries will do all the math for you. And so that's the biggest thing about using all these packages. So yeah, you don't need to actually calculate the gradients or the non-maximum suppression, or you don't need to do any thresholding. All of that is done for you using Opencv. And so the other thing we're going to do is video processing. And so this is just the same thing as image processing, but on video. So we're going to be able to extract different things from videos. The two processing we're going to do is we're going to be actually taking this tennis ball, and we're going to draw lines with it. It's going to track the ball and draw a red line around where the ball is going. That's one thing we're going to do. And the other thing is actually detecting faces on a video. And so we're going to. So you guys have the ball tracking algorithm page with you, and so we're going to go through that step by step as well. And so before we begin, can everyone just open up the Python IDLE on their computers? Oh yeah, and so wait, before we do that, sorry. Yeah, so this is the Opencv documentation. So when you guys go home, if you guys have any questions, if you need to do anything, just take a look at this really quickly because it's going to help you a lot on the challenge I give you. Because one of these is actually one of the challenges you're going to be doing today. So you're going to be using Opencv, and so this is the documentation on the official website for it. And so you can find out basically everything you need to know about Opencv off of that if you miss anything I say today. So just open IDLE on your computers. And use 2.7, so IDLE 2.7. And I'm just going to go over a few things with you before we begin for the people that weren't here for Python 1. And so does everyone have it open? Yeah? Okay. So Python IDLE is where we're going to be doing all of our coding. And so what you see open with all the arrows, that's called the shell. And so this isn't where we're going to write all of our code. This is where we can do single line testing. So one of the functions we went over, does anyone remember what I have to do to print? Something? Anyone? Yeah? Okay. Yeah, Lokesh, go. Quotations. Yeah, and so this is just one of the simpler functions. Hello world. So can I just get everyone to open up a new file? So just go to File, and click New File.
Yeah, also if you have any questions during the workshop while he's teaching, just raise your hand, and me or someone one of these my t-shirts. We also have a lot of teachers here, so we can come around and help you out. Just raise your hand if you have any questions during teaching.
Okay, so once you have your new file open, this is where we can actually write all of our code. And so last time we went over things like the print statement. We went over variables. So you can, let's say, assign x is equal to 2, right? And so that's how you assign your variables. We went over loops, so if statements, else. We went over while loops. So all of these we're going to be using today in order to do image processing. And yeah, so we're going to get started with the canny edge detection. And the way we're going to do this is I'm going to run you through all the code step by step, showing you which packages we need to import. And if you have any questions, like Devani said, just ask anyone in the black, white t-shirts. And so the first thing we got to do in any code is we got to import all the packages we need, right? And so we know to do this, we're going to need to import the computer vision package. And so we have Opencv 2 installed already, right? So we're going to need to import Opencv. So another package we're going to use is called Numpy. And so what this is it basically helps you run math structures. And so so all these math functions, they can be done using Numpy, all the arrays, lists. And so we're going to import it, but we don't want to end up typing like numpy every single time, right? So we're going to import it as np. So this is easier if we just do it as np. And then we're going to import Matplotlib. And so that's what I was saying. It can, so instead of having to do, like I said, for all the other math functions to open up coordinate grids, to do anything like that, we can import Matplotlib. And so that's how you spell it. And, oh, shoot, sorry. And we don't want everything. So another thing about coding is that you don't want to import literally every single thing, right? We want to import as minimum as we can to save space, make our code faster and faster. And so we're just going to import something from Matplotlib, which is just the plotting Windows stuff. So we're going to import from Matplotlib, import pyplot, and then we're going to name it PLT. So instead of, like I said with NumPy, instead of doing NumPy every time or Matplotlib as pyplot every time, we just call it PLT. And so now we're going to basically define a variable, and we're going to call it image. And so img. And so what this variable is the actual image file that we want to process, right? Since we're not doing an actual like live video stream, we're going to import image. And so CV2 refers to the Opencv library. And so this is just the syntax. It's just going to read the image. And the image is named as Devani, like just he gave you all the files, and the image is actually named iron-man.jpg. And so this is the image we're going to run the canny edge detection algorithm on. And so now we got to actually call the edge detection algorithm.
Wait,
and so
just like run the code with just like the image file to see if it executes on all of them.
yeah, sure, you guys can run it.
So wait, so to run it,
Yeah, just go to run and click run module, but make sure you save. Oh, sorry, yeah. Make sure you save your file into the folder with all
so
the.
on desktop, there's a folder called Python_2. When you go to save files here, you want to go to your desktop. And on desktop, there's a folder called Python_2. Make sure you save your file in there because all your images are in that folder. And so when I run your code, it's going to look for the images in the same folder that your code is in. And so you want to save the Python code in the same folder that the images are in. So save the code on desktop in the Python 2 folder. And the name can be whatever you want to name it to be.
Yeah. And so now you guys can just try and run the program to see if there's any issues. So if you don't get an error, it means that there was. Oh, you guys all got errors. Okay. If you don't get an error, it just means that there was everything worked. There was because we didn't actually call.
terminal. So we're going to show you how to do that right now. Because all these packages are connected to terminal. And so if you write all the code in there, you can save the files on using the Python IDLE. To run the files, we're going to use terminal. So Drew will show you how to do that.
Yep. And so on your guys' computers, if you open up the start menu, it'll be called CMD. So just type in CMD and it'll open up a window similar to mine right here. Does everyone have this open? Yeah. Okay. And so what we're going to do is we're going to go into the desktop. So terminal, you can actually do everything you can do on your computer, but through your keyboard. And so we're going to CD, so this is going into our desktop. And then we're going to go from the desktop. We know that there's a file called python_2, right? And so for so we're going to go into Python 2. For you guys, it'll be python_2. For mine, it's python space 2. So just follow python_2.
CD desktop and then CD Python _2.
Yeah. And then we're going to run the image processing algorithm, right? And so the one that we wrote, I don't know what you guys named it, but for mine it was image_prop.py. And then you click enter, and if it doesn't give you an error on terminal, that means that your code is all good. What? Why?
How the module says it.
What? Okay.
That, right? Image prop. So then,
Okay, wait. Yeah, I'm just gonna
go back to Python.
make sure everyone has the same page. Now,
Remember the CD?
is yours on there?
Yeah, you have to go back to the thing that you were using before. Okay, do not. Okay, you guys are messed up.
You guys are all good, right? So just go back to the
Python dash. Oh yeah, yeah, underscore.
We don't need that yet. Not if you want to know where it's going.
I go. Now, here, you go, image prop. Okay, yeah. So, move this. Move this forward. Okay. Image underscore prop dot ty. You wrote ty. Didn't work? Is there anything in here? Yeah, just rename it. Try this. Okay, you know what? Wait, ask Tony. Tony would know. Oh, wait. Rename it back to where it was. Image.
Run it, it's Python, then it's
Oh, okay. I didn't do that. It worked for me. Yeah.
Python's good. Space, and then label prop.
What are you using? Are you using point 12 or point 14?
That's your area. Code is point
I'm using 2.7.
All right. Once everyone's once everyone's terminal window works, just go back to the file like that we were coding on.
Using 2.7.6.
And so we're gonna go forward with the actual edge detection now. So far what we've done is imported all the packages and set our image file. So now we have our image ready and loaded, and we've set up our packages. And so now what we're gonna do is actually do the edge detection. And so the variable, we're gonna call it edges. And so what the variable is actually gonna do is it's gonna go into the CV2 library, so CV2 dot. Every time we wanna do something with Opencv, we're gonna start with CV2 dot. And so that gives you all these options, right? You can see right here. It'll give you all these options. We don't wanna do any of this. We wanna do canny. And so what this is it's a canny edge detector. And so what we wanna detect is we wanna detect our image, and we want to do it to an intensity of these. So this is the syntax for the canny edge detection. And so now we've set up our packages, we've set up the image, and we've set up the canny edge detector. So all of these, so far what we've, so now we need to somehow show it to the user, right? So now all of this, it's doing all the processes, but there's no way to actually show it to the user. And so this is where we're gonna use Matplotlib. And to do this, we're gonna actually plot the image onto an actual window and show it to the user. Does everyone have it? And so this is the subplot. So this is the first thing. Like this is the first image. So this is what the original image is going to show on, and we're going to title that. And so we're going to call it original image. You can call this whatever you want. And so last time we did arrays, we're going to create, basically the title. And so the plot ticks are just basically just showing ticks, and you'll see that when we start the whole process. I mean, when we run the program. And then, so this is just, we're going to leave them blank. So like in the brackets, you can see them being blank, and because we don't want anything on the ticks. And so we're going to do the same thing. So this was for the original image. Now we're going to do the same thing for the image that shows the canny edge detection. So over here, we actually called it image. So that shows that we want to show the original image and compare it to the canny image, right? And so we're going to take this same line, and we're going to make it. So we got to change two things here. We don't want it to be on the same level, right? So we want to kind of show it side by side instead of being stacked on top of each other. So we're going to change this, and we're going to change this to the image that we ran the canny edge detector on. And yeah. And the last thing we're going to do is have the same thing with the title. And so we're going to title it. Except this time we'll do edge image. And so we still didn't show it. We've done all of this stuff on the pre-process, but we still need to show it somehow. And so the way to show it is just going to do plot.show. And so now the canny edge detector is basically done. And all of this should run the program and detect the Iron Man image that's already on that folder, Python_2 on your desktop. And it'll compare it and create a canny edge detector. And so we're going to run it, go back to your terminal.
Yeah, so and make sure you save the Python file.
Yeah.
Control S or file save, and then go to your terminal to execute it.
And so you just have to click your up arrow on the thing if you already had your terminal open from before. And if you run it, you're going to get a figure showing the original image and then the canny edge detector image. And so, yeah.
Can you go back to the POC.show?
Yeah, for sure. Yeah. Did it work for everyone? Yeah, so how we're going to run it is, so this is how the terminal is basically how we should be running almost everything. And so you just run the exact same thing as you did before, right? You run, yeah, it's just that, and then, but you can just click the up arrow command. And then you just click enter and it'll show you this. So here's the one.
You have to use terminal commands. Go to terminal, and then just write Python.
It's case sensitive.
It's the same kind of before, right? You just press up, it comes up. You have to be next to it. Yes, you have to run your terminal. So over here, if you press up, then the same command from before comes up. And so this one didn't show up. So you have an area to write your code and check what's the key.
I'm very used to like, you guys should show an edge section. So we just did canny edge detection, and so now it's everyone just make sure you understand the structure of this program, and I'm gonna make you guys do another algorithm, and I'm not gonna help you on it. I'm not gonna teach it to you or code it for you. I'm gonna come around and help you guys, and same with Devani and anyone else. But we're gonna do a challenge called smoothing images. And so what I want you guys to do is the output should basically be the output should be and so I want you to basically change the Opencv logo. And so I don't know if you guys can see all the way from the back, but it kind of smooths up the edges over here, and it kind of smooths and adds a filter. And so I want you guys to do this using the Opencv documentation. And so one thing you guys will learn most about programming is that you won't know everything, and there's no way to know everything, but to be able to use these resources online is the best way to kind of learn code. And so I'll come around and help you guys with it, and I want you guys to run the smoothing images algorithm on the Opencv logo. And yeah, so create a whole new file and then run it into that same folder. You guys will have the Opencv image in that folder, but we're going to run the smoothing images. Right, and I'll give you guys some time to work on it until 3 o'clock.
So, do it the way you did with Iron Man.
No, you're not doing what you did with Iron Man. You're going to change it up. We're going to do that. You can try what you did with Iron Man on the Opencv logo, but essentially what we want to do is this. Right? I don't know if you guys can see it. Can you? Can you guys kind of tell? Like the fact that it's smoothed up?
Yeah.
Yeah. So like we're gonna smooth up on the right side. So it's the exact same idea in the code. We're just gonna, instead of doing a canny edge detection, we're gonna do the other thing. I'll come around and tell you guys what the algorithm is, but if you guys can figure it out yourself, that'd be pretty cool.
Wait, can you spell that?
And so just remember, the structure is the same. And I'll even give you guys a hint. The only thing you need to really change is this line. That's the only line that's going to change. Alright? Cool. I'll give you guys till 3 o'clock. You have 10 minutes. Let's see, or 11. Let's see if you guys can do this. Yeah.
It'll be faster than internet slow.
And use Google. I really encourage you to use Google. There's the only thing you need to know is the word canny needs to change to something else. That's all it is. Figure out what that new word is. Actually, this line has to change it to 2 more lines, not 1. 2 more. It's going to be that, and then 1 more line, which you need to, I'll give you guys a hint, it's called averaging. I don't know if you guys saw it, but it's called averaging. And so somehow you need to average the image colors.
No, it's no Chris dude.
No, that's a good thing. I want you guys to find that page. That's exactly the page.
Oh, this page. I thought you were saying that's copy Chris. Wait, what?
That's essentially what coding is. You gotta go find your resources. Right?
Yeah.
What's messed up?
Pick it up.
Your code is not. I didn't do that.
I'm ready to learn how to Python smoothing edges.
I like this.
Yeah, it's the same website. Looks good.
Well, I guess I could love this. If you had to do this.
Oh, what'd you say? Huh? What's it? Hold up.
Here, I changed the first thing. First step. Change the image name.
Yeah.
Because you're not running Iron Man. You're running it on Opencv.
OpenCV for logo. Actually, I think it's JPG.
Alright, we have one person that did it in 3 minutes.
I did.
Alright, well, we got 2.
Yeah, let's go. Basically, it's the same thing. Look at the code. So what do we think?
who's got it so far?
I will when I'm done.
Yeah, raise your hand like really high so I could tell like when you yeah. Okay, keep okay.
Yo, wait, dude. In my CMD code, so what do I do again? Image underscore doc dot UI. Where was that?
Yeah, we're running the code. Something's running the code.
Oh, no. I still have to go into the other thing because it's still on Python.
Yeah, so the question is should be on the computer, right?
Yeah.
So the code is the code is something else.
Oh, alright, cool. Did you do yours? Did you do it now? I'm still doing this. I want to learn and
You've done such a good job.
Do you like it? Like, is this a good? Like, I'm trying to just make sure there's a challenge, so they're collaborating and like kind of like, cause like you can't learn every single line of code. It's almost impossible. So I want them to get familiar with documentation, right? Like,
Go
that's
with the
the
global approach
yeah.
instead of
Like
just
instead of
going
like,
line by line.
there's no way they'd be able to understand every single line. Like if I teach it, they're not going to memorize it, right? So I want them to get familiar with the fact that there's a documentation out there, right? That's the point of my teaching. And this kind of has like that whole hackathon
You
environment.
would be a great teacher.
Yeah.
You show the logo one is just what it's supposed to have. Just
Can you see it? Okay, but I think you know the open
Hmm?
Are you smoothing it out?
Yeah, I'm just putting up the code so then if whoever didn't get it.
Yeah.
Just, yeah.
Alright, so like time's up. Okay. So for those of you who didn't get the challenge, this is a new code. We can keep all the titles and subplot. I just combine them into one. But the main part here is these two lines, right? And so what we did is we changed the edge to filter 2D, and we created a kernel. And so this is where we use Numpy to instead of having the 100 and 200, we wanted to do it to a certain degree, and that's what kernels are for. And so this is just a syntax for it, but that's the smoothing. And so the application of smoothing is basically if you're gonna, let's say you have a logo for a company and it's kind of roughed out, or you have a drawing, you can kind of put that through a smoothing algorithm, and you can actually turn it into, for example, a logo, like a drawing to a logo, right? And so I guess that's the main application.
So when you look at the results, actually, it's not that smooth. Is there
I mean, you can kind of tell through like when you look at it like closely. It depends on the image. I just took like the documentation of the Opencv. But if you did have
it is more of an algorithm that you could use, not only the smoothing
the
algorithm.
blurring, yeah.
You could use the glittering or the
Yeah, so like, there's a lot of algorithms to do this stuff, and so the reason we use smooth is just because it's simple, but you can go onto the documentation. The reason I did this little challenge is for you guys to get familiar with the fact that there is a documentation online, right?
So what I'm asking, I guess what I'm asking is, for example, here, is there any numbers that you can change to make this smooth a little bit more?
Yeah, so like you have parameters, right? So the kernel, so if you kind of go around and play with the different intensities, you can figure out what numbers, and so those are all listed in the documentation, like what each parameter stands for.
If you see the TV screen, it's more comfortable for your eyes than the computer screen. Because the jittering is making this smooth in the TV, even if there is less pixel in the TV one, it's not comfortable, but it's little better to see. So that's
break up the jar. Break up the jar.
Yeah, it wasn't that crash. I think the code chat. That's moving up.
Yeah.
Crash.
Live. No one passes it. Hmm? Yeah.
Okay, has everyone got the smoothing algorithm? No? Okay, you guys can copy it and run it. And there's like food at the back now. If you guys want to take like a 2-minute break, grab some food, water. The whole point is for you to go online. That's the point. You need to learn how to use documentation. Alright, we're gonna go back. Oh, did you have a question? And so now we're gonna go back and we're gonna do something pretty cool. And we're actually gonna run a ball tracking algorithm. And so I'll show you what we're gonna do and we'll actually do it. libraries are installed on their computers, right? Yeah, mine doesn't have it installed. It's fine. I'm gonna see like if it works. But okay, we're gonna go to video processing now, and we're gonna do the ball tracking algorithm. And so you guys have all the libraries installed for this as well. And so the explanation for the code is on your guys' table, and I'm gonna explain it while we go through. But yeah, so we're gonna be able to track a green tennis ball, and the video is on your thing on your Python 2 folder. Yeah. Okay. So we're gonna import again. We're gonna import a few libraries, and so yeah. Yeah. Right, I'll just make a new file too. And so again, we're going to import Opencv because that's the main thing we're using to get the camera input. We're going to import Numpy again. And we're going to do the same thing. We're going to import it as NP. We're going to import something called iMutils. And so this goes with Opencv all the time because we use it to make basically tasks easier with videos. So like if you wanted to do resizing or get your frames, basically all these different frames per second changes, or slow them down, speed it up, change the video size, get the length of the video, all those things. Opencv has like 5 lines of code to do that, right? Whereas iMutils, it's a library that we use to do that all in just one word. And we're going to import something called argument parsing. And so what this is we're going to kind of change up what you guys have been putting into your terminal, and we're going to do this with argument parsing. And so this is how we can add our own commands for terminal. Basically, we can make our own for you guys to put in. And then the last thing we're going to import is from from an already existing Python package called collections, and we're going to import deck. And this is just another type of data structure that we use. So we use integer variables, we've used arrays, we've used lists, and deck is very close to lists. It's a deck. Yeah, so that's all the packages we're going to install. And so we're going to create a new variable, and this is going to be our argument parser. And so this is how you're going to be able to create your own terminal commands. And so the syntax for this is just as goes. Okay, and we're going to add an argument. So we're going to add something that you can put into terminal. And so how you're going to do this is you're going to call your argument parser. And so the variable that you just assign AP is actually basically like the way we were doing cv2 dot. Instead, we're going to do AP dot because that's what your argument parser is called. That's the function that you're calling. And so this is where we're going to put in our where the location of the folder is. Where the location of the video is. And so how we're going to do this is we're going to go through to our file and to see where the location is. So go to your desktop and open up the Python _2 folder that you were given. And find the video that's called input.mov. So that's the video. And what we're going to do is basically get the path for it. Wait, how is it on Windows? Make sure they. Okay, yeah. No, check on Windows. Is it the same thing? It's the same thing, right? Okay. And so we're going to copy paste that, and we're going to call it input. Oh no, wait. We just want to give it the folder location. Just leave it at Python 2. And so we're going to add our next argument. And so in this one, we actually gave it a default. But if you were to code it, and if you were to, if you wanted to change it, you can change the buffer size. And yeah, so we're gonna keep going. Same thing, we're gonna add a help. And so that last line just, it calls all these functions into that last line. And we call it arguments. And so now we're gonna get with the actual ball tracking. And so this is just basically to ease up how we run the code. It doesn't have to be there, but this is just something that you guys could take away and user functionality if you were coding, for example, as a product. And so yeah, we're gonna give it, so we wanna make the ball green because that's the color of this tennis ball. And so we're gonna name a variable which tells it that the color is green. And so how it does this is we make a function, we give it the RGB values that's around this color. And so I've already gone online, sorry, HSV, not RGB, but HSV values that are, so it's around the same, like it's the same concept, it's another color space. And so instead of red, green, blue, it's just another type of hex deck. Is it hex deck? But like, yeah. Yeah, so like it's just another way to give it numbers to turn it into colors. And so the color, the numbers that turn it into this green is 29, 86, and 6. And so we're going to create two bounds. We're going to create the lower one and the upper one. And so when it recognizes the ball, it can draw a circle around those lines. And so we're going to create another variable. And so all of these variables are going to be used when we actually call the ball tracking function that we're going to define in future lines of code. Let me know if I'm going too fast or too slow, by the way. So this way we could call the buffer if we need to, if we want to change it. And so now here's where we're going to basically give it a way to do one of two things. The first thing, which you guys, since we don't have webcams, what we're going to do is we're going to give it the option to use a webcam. or you can test it on the video that I made with the tennis ball. And so how we do this is creating if statements. And so we're going to do if not. If you don't get basically an argument that we created up here, if you guys remember, for the video. So if you don't get an argument for the video, .get, right? It's basically English. If you don't get an argument for the video, you're gonna run the, and so you need to tell it that you don't get it, right? So false. And so if you don't get that, you're gonna give it like a video capture. So you're gonna capture the video. So from the webcam of the person. And so when you want to capture the video of something, the index that we use is 0. So if, for example, you didn't want to actually capture the video from the webcam and you wanted to put your file name, you can put the file name in there, or you can just put 0. And when the compiler reads 0, it understands that it needs to use the webcam as its input for the video.
And so if you have 2 webcams, the second webcam would be 1.
1, yeah.
2, 3, and so 0 is like the default webcam on your computer. These computers don't have a webcam, so we use the video that's on the.
And so to do that, we're gonna create an else structure, right? And so what the compiler is gonna do is it's gonna read through, and when it gets to if not, okay, so you don't have, you do have a video, so so it's going to ignore that if not statement, and it's going to go to the else statement. So here we need to tell the computer that you need to get the actual video. And so how we're going to do this is that we're just going to capture the video. And so now when you go into your terminal, what I'm going to show you with the argument parsing is you can change the video name and it won't affect it, because how we did it is we ran an argument parser. And so from this, when we type into a terminal, we're going to type in the video file there instead of here. So if you had other videos, you can change the name.
And just before we go on, something we covered in the last Python thing was if and else statements. And so the computer has to know that if this condition is true, then run a certain block of code. If that condition is not met, then run the other block of code. And so to know like which block of code to write, different languages have different syntax to like tell the computer. In Python, to tell which line of code to run, it has to be indented. And so you can see this block of code, it's indented, which means the computer knows that if this condition is true, then run this first indented code. If it's not true, then run this indented code. That's why it's very important in Python to have proper indentations. If you indent this by accident, then you will get an error.
Yeah.
And different languages have different things. For example, in Java, you actually have like curly braces, an opening and a closing to tell the computer. In Python, it's tabs. That's something we've covered in Python 1.
Yep. And so the next thing we're going to do is run a while loop. And so we covered this in the last workshop as well. But a while loop just takes a condition and it'll keep looping it as long as Devani mentioned, as long as it's in the indented block. And so we're just going to make it while true, which basically means while 1 is equal to 1. It's never going to change, right? So while true is just while it's forever until you break the while loop. And so we're going to obviously set something to break it so your code doesn't basically glitch up your computer. But as long as the fact that true is true, which it can never change, it's going to keep going through that indented block of code. You can make true, you can make it 1 equals 1 as well. So it's whatever you want, but yeah, we're just going to make it true. And so what it needs to do, the first thing it needs to do is actually open up a window, and it's going to read your camera, or it's going to read the video file from the from the if statements or the else statement. And so this is going to basically be called camera.read. And so camera is the variable we named up here. And so it can be one of the two, right? It can be the video capture from your webcam, or it can be the video capture from the video. And so whatever it is, it's going to create a new frame and call it frame. And so if it gets an argument from the video, then it's going to do again, another if statement, which we did, so we did it up there. Now instead of if not, we're going to do if. So if this condition is true, then it's going to do whatever's after the block of indent, right? And so you guys can follow along to the explanations too in that sheet I gave you. So if something doesn't make sense, you can look at that or ask a question. But yeah, so what it's gonna do is basically, if you're like viewing the video and you don't get a frame, then it's gonna basically it's reached the end of the video, right? Like you've gone through every single frame of the video, and so that's when you just break that loop, break the if statement. And so, as I mentioned before, we use imutos instead of Opencv for this, for all the frame functions, because it just makes it less lines of code. And so that's the whole point of using packages, is to minimize the amount of code you need to write, make your code faster, make it easier to read. And so we're going to use imutos to resize the frame to what we want. And so we're going to resize it to, I guess, width 600. And so these numbers are pixels. So so the width of 600 pixels on your computer screen.
I'd really want to just get a window with just the video on it's the blank one. Just get
It's not working on mine.
so we could do all of it, they won't get it. So just do these two lines. So from here, see to the I'm show, and then if how to close the window and then to release it.
Just a new window. Like let's do it on new.
No, on this one. So just all the way to the bottom right here.
Yeah.
Just keep going right.
Yeah.
And so instead of HSV, start with this. See to the I'm show.
Okay, just see
Yeah, right here. Yeah.
Okay.
See your finger? And
Yeah.
go all the way to the bottom.
What?
From here to
Yeah.
the bottom? Oh, wait.
Okay. And so we're gonna just take a slight detour, I guess, and we're gonna go and run the video just to make sure our code is still working, and we'll continue with the ball tracking now. And so what we're doing here is basically doing all the stuff that we should be doing basically at the bottom of our code to tell our computer to actually show the window, or what key to press when you want to exit the window. And so we're gonna do, and it's gonna wait for that key. And yeah, so the index.
Yeah, so this while loop, it's gonna keep going through the entire video, frame by frame by frame, and it won't stop. And so let's say and it won't stop until it's gone through all the frames. If you want to stop the program during one, so let's say midway through the window, we can tell the computer, okay, how can I stop it? So what Drew's doing over here, he's telling the computer which key is pressed that the program will stop and it will exit the program, because it's going to keep going either frame by frame by frame. Yeah.
What is 0
Yeah.
X?
So this is actually a hex code for the key itself. So each key is mapped to a specific hex code, because we understand it as a queue, but in programming it's not actually like the representation of that queue in programming is like the 0x. And so for each one it's going to be a different one.
And so we're going to release the camera. I mean, we're going to basically release the whole, that variable that was grabbing the frames. And we're going to destroy everything after we press Q, right? And so we're going to run this. And save it to that file again, Python_2.
Yeah, same folder.
Same folder, because that's where your.
Yeah. And if you want the colors that's showing up here, here are the syntax colors that make it easier for you to read your code. When you're saving it, make sure you save it as the name.py. And then it'll give you the colors.
And so we're going to go back to our terminal, or for you, yeah, CMD, and we're going to run the program. do the video? Yeah.
Yeah, you have to go to video.
Hmm?
Yeah.
Input data. What was it called? Was it input data MP4? Because it didn't tab fill it. Input data movie. Invalid syntax. So I.
You can come off the video.
Hmm?
After video?
Yeah.
Come off.
Oh shit. Oh yeah. Yeah. Code. Do you see it? 26.
If you want to read, it has to be after the read, you need to closing curly braces.
Where?
Like you need to.
Oh yeah. What? Why is wait key?
It's CV2 dot read. K is capital wait key.
Oh yeah. Okay. And so wait, there were 3 errors I messed up on. And so the first one that I messed up on, so this is what terminal is good for, I guess. I forgot a comma after video in this line, right here. And so I don't know if you guys did it, but yeah, and then the camera dot read over here has to have brackets, the 2 brackets at the end because it's a function, and so functions always have brackets at the end of it. And the last is over here. You have key is equal to cv2 dot wait key. The k in wait key is capital. And so if you save all of that, the terminal command now is Python whatever your name, the file name is. And so remember how we did the argument parsing, right? And so we have ball tracking, and then we're gonna have dash v because that's the index we gave it from before, and we're gonna have input dot mov, and so that'll run the file. And press Q to exit. X won't work. Oh, it's on a live stream, so maybe that's. I'll just put it down.
Can you pick up the CMD?
Oh, you don't. Oh, okay.
Thanks.
Yeah.
you show.
Are you getting a call? You need to make sure you can. So for your line, this all has to be part of the loop, right? So this all has to be part of the loop, and so I'm going to push on. So this has to be part of the loop. It has to all be in there.
All of these orange ones?
Yeah, in Python, make sure you follow the spacing and especially in indentation. Okay, you can promise it. Okay, so we did this, and then so what we did in our code was we said dash b, and then we did it in the file. Did you save this to the same?
Make sure you spell collection right.
Collections S.
Make sure you have attached the video file to it.
It looks like it's like it's
so now we know that the videos are loading. We're gonna actually do the ball tracker. And so we gotta go back into the part. So this part right here should always be the end of your code, and it'll be the same for most Opencv applications. Because this is where you can change Q to escape or A or B. But this part of the code is basically the same structure for all for most Opencv code. So we're gonna keep going now. Back to where we were, and so we were right around here. All right, sorry. Right around here. Okay, and so just press enter so you can kind of just start coding there. And so now we're gonna define basically what the color, basically the color space. So the HSV that I mentioned earlier instead of RGB. And so what that's gonna do is cv2.cvts. Okay, so that's the new color space that we're going to be using, which we kind of did up there with the upper bounds and lower bounds. That's going to be what we put it on.
So take out everything after the.
No, don't take it out. Just press enter, and so because we're gonna, or unless you want to type it all again, but just press enter so then you can.
All right.
Yeah. Okay, and so now we're just gonna create more variables. So now we're basically telling it that if it's in this HSV color range, so if it's this color, we're gonna store that color basically into a new variable. And you guys should remember what. So we did define all these variables up here, right? So we defined green lower, green upper, and we defined HSV. So now we're just putting it all into one variable and calling it the mask. So that's basically the mask of the ball. And so we're going to give this variable some more properties just to make our ball tracking a little better. And so what all these do is basically it removes basically all of those like blobs that are left in the mask. So anything that's left around the ball when we're tracking it that it could recognize as multiple balls, we're basically getting rid of that when we're coding this. And so now what we want to do is create an outline for the ball to follow. So once it recognizes the ball, which we did, we want it to draw a circle around it so then it can follow it, right? So basically for a computer to get an easier follow. And so it's just going to draw a nice little yellow circle around the green ball. And so we need to tell it that that mask variable that we already got in the earlier code, it's going to take that variable and copy it onto here. Just make it easier to read. Okay. And so now somehow we gotta tell the program to only process this algorithm if at least one ball is found, right? Otherwise it's gonna think every single thing it sees green is gonna be a ball. And we don't want it to draw everything, right? We want it to see the ball and draw around the ball. And so somehow we gotta tell the program to do this, right? So that's why we made this whole variable called CNTS. So it basically, it's contour, which is the outline of the ball. And so if it recognizes that there is something there, only then will it actually do something, right? Only then will it actually draw a line. And so it finds it by that CNTS variable. And so this color of ball can be different, right? I mean, sorry, the size of this color ball can be different. So how are we supposed to tell it to make what size of contour, right? We want, or what size of outline? Because this one can be this small, but then if we have a bigger one, it can be bigger. But we want it to still follow and draw that outline around that bigger ball or smaller ball. And so we need to basically make a variable to get the size of the ball, right? That's what we're gonna do. And so using this function that Opencv has, which is contour, and contour area. So what's the area that the circle encloses, right? And so we can get this by using this function. And then it'll turn it into basically, computers use a lot of math, right? And so it's gonna basically understand it through math, through like all these variables and coordinates, right? And so we need to give it that ability.
And be careful about the indentation. This one's indented twice, but it's inside the loop and it's inside this if statement.
Yeah.
So make sure your indentation is right.
I just, okay. So this is what I said about earlier with the Opencv and how we don't need to do all the math, right? We just need to give it the variables and it'll do all the math for you. And so that's all we're doing. We're just giving it, okay, so the variable is going to be our counting variable and it's going to be our radius, and you can do all the area calculations for me. But realistically, in the Opencv, in the actual Opencv code that we imported, in that all these calculations are done. But we don't need to do it. make sure there were a lot of brackets here, so just make sure all the brackets are filled in properly. I want to make sure I did too. And so yeah, see, I missed one. Okay, so now using all of this, we were able to tell it what the radius of the circle is, right? And the area of the enclosing circle. And so what we need to do is basically tell it that if the radius is bigger than a certain size, only then should it proceed, because we don't want to track too small of a ball. So yeah, instead of like tracking a jumpy ball, we're going to track this tennis ball. And so we're going to say if the radius is bigger than 10 pixels. So remember, every time I'm going to define a number in terms of the Opencv values, it's going to be in pixels. Then it's going to basically draw a circle around that ball. And so Opencv makes this really easy. You just say circle, and then we just give it what frame. So we had defined earlier what frame was. Frame is basically the actual window. And so in that, it's going to draw a circle of integer x, which was over here, because integer x is going to be, it's related to the radius, and integer y. And of course, we need to give it the radius. And so that's the size of circle that it needs to draw. And so what color we're going to give it, we're just going to mix it, make it. And so we're just going to make it yellow. And so yellow, this is going to be the RGB value.
Is that RGB?
Yeah, it's RGB.
Well, that's cyan.
No, red, green, blue. Green plus blue.
Oh, is it in reverse?
RGB, red, green, blue, right? So 0, red, and then we're going to give it green plus blue. Oh, shit.
Green plus
Green.
blue is cyan.
Green plus, okay, we'll just make it cyan then. Let's keep it that. My bad. Okay. Do you guys want to make it yellow? I mean, it doesn't really matter what color you guys want to. 255. It doesn't really matter. Like, do you guys want to make it a specific color?
No.
Okay, we'll just keep it this then. Sorry. And so now we need to get out of this loop, out of both if statements. So before I move on, just make sure over here we were inside 2 different indentation blocks. So it's going to be kind of confusing, but we were inside 2 if statements and a while statement. So that's almost 3. That's 3 indentations for these last ones. Just make sure all of you guys got those indentations right before I keep going. Sorry. That is full screen because I'm on live stream, so it's the screen's a little small.
Yeah, but if you zoom in, then you'll be able to see that.
And so I'll just go back out to the loop. So the loop starts at the very end of the screen, and then so we're gonna go 1 indentation in for the first if statement, and so this one goes. So up until here, you guys should be fine. And over here, just make sure everything's good. Oh no, we have a few more lines to go. And so earlier we basically made a variable. It's called PTS if you guys scroll up. And that was the points. So we used a type of data structure, it's called dec. And so those are the points we gave it. And so we need to update it, right? We need to tell it that we got all of this for the compiler to read. Because we did a lot of this stuff, but we need to make sure we're still updating the variables that we're going to be using. And so over here, we're just going to update the variable PTS. so this is exactly how we defined it earlier, right? And so PTS dot append left center. And so that's the points queue. So that's the points that we've given it from before, and so we just need to change them over here. And then we're gonna use PTS to create another loop. And so this is the last exactly how we're gonna show. So the points queue is basically when we're gonna be using this ball, and when we put it in front, it's the points that's gonna draw the line with, right? And so we need to tell it using this variable. And so we're gonna loop as long as it's in that range. We can actually draw that line behind it. So far what we've done, we've imported the packages, started the command line, and then we've gone and we've tracked the ball. Then we've created a circle around the ball, and we've given it a variable to be able to draw the line, but we haven't drawn the line yet. And so that's the final thing. We need to actually draw the line behind the ball when it's tracking it. Again, make sure you're following the tabs, because this is where Python ends up getting very messy, is when you start messing up all these tabs, because you have so many loops. And so here we're just going to give it the thickness of the line. And so we can either give it a number, or you guys will see when we do the actual algorithm, we're going to make it a cool, it's going to actually change. The thickness is going to change as it goes. And you'll see that when we actually run the code, but this is just, again, the math that the library does for you, and it looks cooler, so we're going to do it that way. But if you really want to, you can actually make the thickness and random integer like 2, and it'll make the thickness of the line 2 pixels. And so the thickness changes using this little formula. Okay, and then the last thing is to basically draw the line using cv2.line, and that draws the line for you. And we need to put that into our frame. Again, has to have the same points that we used earlier. And so and so yeah. 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 So now we're going to run the program. 160. It's in this line.
Minus sign.
Where?
Backspace and accordion.
Minus sign?
Yeah. It's not dash, it's a minus sign.
It is a minus sign.
It's a dash or the minus sign.
A minus sign.
Click on again. Line 16. Wait, we can put back curly brace. This one opens here. Closes here. On the thickness, I need a curly bracket.
Is it?
At the end. No, the opposite. Line 1.
Where?
In the line, at the very top.
Oh, yeah.
Don't forget your curly. Don't forget closing and opening curly bracket.
What?
The R's have no range.
Wait. Which line? What's it? Line 33. Just go help them with theirs. I have the thing, right? So.
The R's capital in it.
Okay, that's what it should be. Okay, so there were a few errors in my code again.
I have a weird confusing error that you have on.
Which line? Okay, I'll just go over the ones that I got, and then if you guys have any other ones, I'll come and answer them. The first one I got was over here. I forgot to add a bracket after simple. So if you just scroll up to that one. And then over here, right before int x, there's actually a bracket, and right after int y, because it's one number. And then over here in the line that has thickness, there's a bracket at the end that I forgot to include. Right here, this last bracket. Just make sure you have it. And those are the errors, so if you just go and run it, it should run. Yeah. Simple? Yeah. I fixed it here. What? What's it?
you done? The reading my stuff? Right here. For you?
Oh, you know what?
Okay, right here. Like, no attribute in range.
Yeah. Oh yeah. So last one was. I'll just go. It shouldn't be in the So on line 33, if you guys haven't kept the same lines, but let me just go. Yeah. So over here, the first time we define mask, it should be a capital R for in range.
Anything in mind is perfect. I'm just asking.
Just like go on the left, I'm gonna go down or up. Maybe you should see it.
Okay, so which one? What line is it?
More or is this good enough? What? Oh. What? Scroll up or down?
Did you write X range? Did you write X range? It's used to write X range. Object for I, and then X range. Now save. Save button.
I did say.
Can I try again? Line 56. What's the next line? Okay. Good thing on.
Oh my god. I put a N instead of a C. So it changed everything. Yeah. It changed everything.
So see, this is what I need.
Hey,
These are our YC members. It didn't matter. Or I need to go. This looks very good. It works. Oh. What? Go to line 9. That's where your mistake is. What is this? This is not the code. This is something else. It's not highlighted. It's not even. It's not highlighted. Look at it. It's not even right. Why do you so many random things? You have randomness what? This is fine. Somewhat fine. Yeah, this is, your tab should be there. What are you guys doing? Both of you are useless.
All of this, man. Then you did some one-half thing.
Yeah, you see Niels? Go look at Niels. Go look at Niels.
This is something
I don't know what he's doing. Look at it.
I tried to follow this.
It freaking works for us.
So many random in there.
Wait, what?
I think you just forgot to.
No, I tried to follow this man over here, right?
Okay.
But then what happened? He did like one backwards and everything else was like. Then I tried.
Don't even mess around here.
Wait, what happened? Where did you like the face?
Oh, it was like on the front.
What? No. Stack overflow collector.
Oh, yo, watch it.
So yours is what? Keep it 100. I'm making it actually do 1,000. Craig, do you like this? Why don't you like this? Honestly, that's what I get laid off of though. That's what Chris did. Chris did stupid. I didn't.
Yeah, now it's just like open. Oh my god.
It's not the problem. Collection, it's not collection. Yeah, it is collection.
Dash V and then input dot chapter.
Okay, the thing is though, none of these old bars, it's bars. You have to remember the S's, bro. Like God. Oh, 38. 38.
I'm going down video. I'm going down. Negative E and then dot log. Remember? Yeah.
Go to 38.
That's a negative B. Oh, there it goes. We're going down. Okay, I'm screen it. Okay, fine. There. No, I need to work on it.
It's 3 YC. I know, and you're struggling to do that. What's finished? This is working. You had always Box FX.
It's 0, not yeah, good one.
Why is it so skinny, bro?
Yeah, honestly.
Yeah, make it 20,000. It's actually very
Oh my god.
Look, I'm going at 20,000.
No, that's the color.
Loki, look at
You could change that.
Loki.
Input dot M.
I'll just have it in flight line. Yeah, yours is the best.
Honestly, I like that. Go make it fatter.
Oh, wait. Oh yeah, the tags, that's what.
Go copy off the.
It's right there. Go copy off.
Let me look at that.
Look at that line that says center is equal to
Foundation. I got my tags are correct. So this one ends up
Yo,
happening.
what are the tabs supposed to be?
I have everything right except the tab tags.
I'll find the tabs to take for 2 years.
Can't got the video. Okay, that's good. That's good. Please, that's a professional. Okay, chill on it. I'm opening it. There you go.
I actually broke it. Yeah, it doesn't work anymore. Happy birthday app done. Oh. तो पैसा पे था? अबे आप भूख लगी? आनो भूख लगी.
You deleted my entire code! You deleted my
Go open it again.
It's over here!
Open it.
With what?
Eat, got it. Friend in need, a friend in need. Thanks. I've been doing pull-ups, doing big.
It's video.
I didn't think it was Python 3
And so, okay, wait. Everyone just like sit down.
You guys sit down.
What was the problem? I didn't remember this grammar right in here. Oh, yeah, 2x. Oh my god, this is nuts.
Oh, who did this?
Okay, everyone sit down. And so we're gonna keep going. And we're gonna do one last thing. We're gonna detect the face in that same video. And so, wait, before we do that, I actually just want to show you guys how to do the ball tracking on real-time feed, right? And so, okay, actually I'll do that one after, but yeah, so we're gonna do face tracking now. And so, you're just gonna open up a new file, and you're gonna just same thing. We're gonna import CV. This one's really simple. And so in that Python 2 folder, you guys are gonna have something. It's gonna be called har cascade fronto face default.xml. And so we're gonna use that to be able to detect someone's face. Now that file that's called har cascade, is actually it's basically again pre-written code, but it actually uses points on basically on your face to be able to detect that this is a face and this isn't, right? And so in that screen, it'll be able to tell what your face is based on that file. And so that's what it uses as pre-training. And so what we're gonna do is we're just gonna start our camera, and we're gonna name it again. We're gonna have to video capture. So video capture. And so here again, we can do 0 to get our face, or we can just do so 0 to get the real-time feed from the webcam, which you guys don't have, or we can just do that same video again, and we can just start it here instead of going through all the argument parsing. And so next, we're gonna have to give it some sort of way to be able to detect our face. And so to do this, we're gonna give it the cascade. So we're gonna name this variable face_cascade, and we're gonna call the basically call a function that can give it that can help it classify the face.
Maybe explain the cascades there. Cascades, can you explain how it works?
It's just a pre-trained thing, right? Like the machine.
Yeah,
it's
right.
machine learning. It's like
No, here, it's right out of that short.
okay. Do you want me to open it?
Yeah, I'll open it. Just
Okay, you want to open it?
good for you.
Don't you just want to like actually open it?
No, I'm asking about that. Okay, so I'll give like an overview of how like this cascade things works, right? So on that one line that Drew wrote, it took in an XML file. That file has a bunch of like different integers and math values that's doing this over here. And so like how this one way of detecting faces is looking for different like patterns in the face, right? If you notice in like all the images of every single human, it's darker by your noses over here than it is over here. So what the algorithm does is that for that feature over here, it checks if these pixels around the nose are actually darker than they are in the middle. And so there's different features that they found, like for the eyes, it's bright over here. And so there's different features that someone has already found, like someone around the world has found these features and created a .xml file for you. If you had a different object, you can actually make your own features like this, like for let's take a chip bag, and then make your own XML file for it. But let's take a quick 2-minute of how this works. If you look at how cascades, you can actually learn more about it if you want. And so going back to the code.
Here's an even easier example. So this is another basically XML file that's used, right? And so it basically points out 68 parts of your face that can detect if it is a face or not. And so it uses these, and so these are the basic features of a human face. Now, obviously, we all have different faces, but to be able to detect just that it actually is a face, it uses different landmarks in this one, or in the hard cascade, different, I guess, pixelations. And so now we got to do the same thing that we did earlier, right? So we're just going to start another while loop. So it keeps going until we actually stop it from going. And then we're going to give it again a whole new. So you guys will probably recognize some of the syntax from the code that we did earlier, right? So again, we're going to start a frame, start a whole new window, which is going to read all the video that we had, the input video. And so, and we're going to name the frame.
Yeah, it's cut off over here, but it says .xml, and then there's a closing bracket. For the way starting, the screen's is kind of too small, so there is one over there. Yeah, keep going. See, there is like a closing bracket after it. It's kind of just too big.
So now it's going to actually use that cascade that we had, the har cascade file, which is stored into this variable called face_cascade, and we're going to detect basically a face. And so now we have a bunch of different values that we want to make sure actually fit the category of a face, right? And so this is the standard in face detection, which we have all of these different values, and make sure it's in this variable that we called faces, which has the cascade actually detecting faces. And then from here, we want to actually draw a rectangle to point out that it's a face. We'll draw a rectangle around the person. Around the person's face, sorry. And so these are just the dimensions of the rectangle that we're putting out. Of the person's face, obviously. And this is the color. And so now we're just going to do that same last little bit that we always do, which is just making sure that we show the frame. So cv2.im show. And we need to give it a way to actually close the frame. And so it's the exact same code, right? Sorry. Okay. So yeah, this last bit we went over it in the ball tracking, and so this realistically the only lines here that are actually doing the face detection is just the ability to get the cascade to actually recognize it, and then we're drawing a rectangle around it. There's only 2 lines needed to actually do the face detection. The rest of it is showing the frame and breaking the frame. And so has everyone got it, or?
No.
Yeah, once. Oh yeah, make sure you guys have these.
Alright, what's the rest of that line up there?
Which one?
Space, X and L, yeah, and then an apostrophe, and then a closing bracket.
Oh yeah, make sure you have the right capitalizations. Yeah, so it'll actually detect that there's a face in that video. What? Yeah. Sorry.
It's destroyed all windows.
Yeah. Do you have a question?
Why did it say it's doing this stupid thing, CVP stuff? There's not supposed to be rough. So why does it be twice?
You guys are missing the delete cascade file, so we're just gonna get that soon. Yeah, he's just getting it to you guys.
Should. Why do you have all these lines still? Yo, actually, please, I need help out right now. I don't remember anymore. Don't be a faggot.
I'll tell Rachel. Attribute. So it means that you're going into this library, so I'm going to do CV2.
Rachel, wait.
It thinks that you're going into the CV2 library to get
Am I following her yet?
So this one has a space. This one has a space.
So the exact spaces won't.
Oh, yes, I am following. Okay. Chris. Chris.
You don't want your girlfriend?
Chris, choice aati bhanga
Your
rahi.
friend.
Chris, koi biji ka to choice aatli bhanga kari.
I didn't do it.
Aatli bhanga choice kara di basi. Oh, but she's scared. Chris is snowboard. It doesn't work. No, yeah, word. Snowboarder. Can't even go down clear water without falling.
She's doing the block shot. Okay, she's not scared too. Is this
On the ball, real quick. Guys, don't forget the ball. Okay, Chris, see you.
everyone detecting faces?
Okay, now help me with this.
Rachel.
Rachel. Oh, I had a picture, but I unfollowed. I shouldn't have go. Yo, okay, can you see stupid error? It's saying color BGR 2 British on the line.
It's like 7 minutes of get up Okay, so did everyone get both of the things working on it? Yeah. Did everyone get the ball tracking and the face detection working? Yeah. Okay, perfect. You guys got a ball tracking explanation sheet, and so that sheet actually explains everything line by line in more detail. Well, not more detail, but like in detail, so if you guys do get stuck. And so, yeah. You guys didn't get the sheet? Crap. Oh, crap. Can you get the ball tracking explanation sheet? Ball tracking explanation sheet. Can you give it to these guys? We'll get it. Okay, he'll get it. 20. Cascade. Cascade. Okay, so yeah, you guys will get the ball tracking sheets. So those sheets actually explain everything pretty well too. And so, like I said before, there was the Opencv documentation. So obviously, I can't cover all of these different types of algorithms in 3 hours. So you can go on the Opencv documentation. The 2 algorithms that I chose were actually, I chose them because they have the foundations of most algorithms, which has the whole edge detection and the smoothing. Those 2 were pretty straightforward in the foundation, and it was very basic. But there's algorithms that you'll see the effect on. Like we did contours. Go up. We did contours in that ball tracking in the ball tracking application that we did. And so, yeah, so I'm gonna give it to Devani to like let him speak about Community Code Day.
I had a question there. Asking if we could have like face detection and ball detection at the same time.
Yeah, so like that's why we can use that video and we can do both at the same time, right? So in that while true loop that you did, you can do both at the same time. I mean, we don't have time for it right now, but I'm sure you guys can figure it out when you go home. You guys have the code for both, right? You just gotta combine the scripts. And so I'm gonna let Devani speak a little bit about youth computing and Community Code Day, and we have certificates for you guys. Yeah.
So yeah, Community Code Day is going to be this coming Saturday and Sunday, and it's actually a technology conference in that like throughout the 2 days, the first day is going to be a bunch of whole different speakers. It's kind of hard to read, but it's this community technology entrepreneurship. It is 1 hour session of this by speakers. At the same time, there's going to be three different workshops going on. And so in Python, you're going to learn how to make your own art gallery. In web development, you're going to learn how to make your own web portfolio. And in virtual reality, you're going to make a VR art gallery too. And so Python one's going to be an art, not gallery, but an art like editing software they're going to make in Python. And that's the first day. And also, besides these workshops and the speakers, there'll be space to code for the people who want to like just get help on their own project. Let's say if you're working on like a side project for your school or for your business, you can get help from like experts who know coding, like teachers and stuff. And then one stream is just the conference. You can also choose to compete. And if you choose to compete, you're paired up in teams, and then you have a chance to win prizes. And so if you're competing on Sunday, there'll be judging going on and public viewing, so you can show what you made on Saturday, and you can be judged on it. And then there's different prizes, there's different cash prizes from based on different categories, so like best project in Python, best project in web development. And since the theme is arts and culture for this year, if your project addresses like the arts, let's say a painter wants like an app that can detect what color the flowers are. Like, if he makes that, then that's like a higher score for him for the team. So there's different awards, and we also have 2 different keynote speakers on day 2. So one of them is from SMS. He's going to talk about autonomous haul trucks, and the other one's from Syncrude. And he's going to talk about VR and how they use VR to train their employees in their workspace. So it's both days. This conference is going on. It's going to be here at Keyano. There's going to be food given for both days, so breakfast, lunch, and a second lunch for both days. And it's all free. It's open to everyone in the community. So spread the word. And RSVP on communitycodeday.com. The simple registration form, that's your name, that's your email, and then which ones you actually want to attend. So RSVP, spread the word, and we'll give you certificates. Any questions on Community Code Day? No?
And so if you guys have like any questions even relating to a project on Opencv or something, you can feel free to shoot an email to the youth computing email or the Community Code Day email. We can help you out with that too.
These are some of our speakers. If you go on our website, you can like learn more about them. Like, they all have bios and stuff. They're actually pretty cool. So,
okay, so I'm gonna give out certificates, and so when I call your name, just come up, and we have a certificate of completion for Python 2. So, Chintan.
Pram, can you turn the lights?
Share. Barbara. Abdullah Zahid. Lana Wang. Shan Awan. Saptarshi. Willem. Uday. Sparsh Patel. Shreya Patel. Sharar
notice how they're front and extend? You have to give them? Yeah. Yeah, we'll get the chair. Notice how they're front and front.
These are all kids.
Okay, squeeze in, like, don't, like, guys, camera's up the lights.
It's gonna. I'll stand tall.
Squeeze in, squeeze in, squeeze in. Squeeze in.
Don't cover your knees. You want me to come down?
Ready? One more.
Thank you. Come out to Community Code Day. Now you have to mais.
And I have a further explanation. The ball tracking.
Like the paper card?
Yeah.
Okay, yeah. Just ask Crown. Yeah. If not, then do two and then you can make a special code or the ball tracking. Oh yeah, we're gonna email you guys all the code. So